Welcome to the deep dive. Today, we're tackling a really core concept for anyone aiming for those senior software engineer roles, design patterns.
Yeah,
It's
exactly.
not just about, recognizing them. It's really about showing you can use them to build systems that are robust, adaptable.
Adaptable. Think of them like proven blueprints, for solving those tricky design problems that keep popping up.
Right.
And today we're zeroing in on one that, well, it really shows off your architectural thinking in interviews, the visitor pattern.
Okay, the visitor pattern. So our mission for this deep dive is pretty straightforward. Give everyone listening a solid practical handle on it.
Yeah.
We'll break down the problem it solves, how it's structured, its pros and cons, and really crucially, when it's the right tool for the job, all framed, for those senior level tech discussions.
Perfect. Let's do it.
Okay, let's unpack this. So imagine you're building something complex, lots of different kinds of objects floating around.
Picture this. You've got a system, maybe like a compiler, dealing with different bits of code, like assignment statements, variable references, function calls, all distinct types of objects or nodes in a tree.
Right, a whole collection of different things. And now you need to do various operations on all these different objects. Maybe you need to type check them or generate code from them or maybe just print them out nicely.
Yeah, lots of different potential actions.
So the maybe naive approach is just add those methods, type check, generate code directly into each object class, right? What's wrong with that?
Well, that's where things start getting tangled pretty fast. Your assignment node class suddenly knows about type checking and code generation and pre-printing.
Doing too much.
Exactly.
Huh.
It violates the single responsibility principle. The class would become bloated, harder to understand, harder to maintain. And think about adding a new operation.
Oh, yeah.
Like, say, you want to add code optimization. You'd have to go and modify every single node class, assignment node, variable ref node, all of them.
And recompile everything.
And recompile, redeploy. It just doesn't scale well. It makes the system rigid.
Okay, so that sets the stage nicely. And this is precisely the problem the visitor pattern aims to solve, right? It lets you add new behaviors, new operations, without actually changing the classes of the objects they operate on.
That's the core idea, decoupling the operations from the object structure itself.
It sounds almost magical. How does it actually pull this off? What's the structure?
Okay, it uses this clever setup with basically two main hierarchies working together. First, you've got the element hierarchy.
The objects being operated on.
Right. The nodes in our compiler example, assignment node, variable ref node, etc., they all typically inherit from a common base interface or abstract class, let's call it element or node.
Okay, that's one hierarchy. What's the other?
The other is the visitor hierarchy. This is where your operations live. You have a base visitor interface, maybe node visitor, and then for each distinct operation you want to perform, you create a concrete visitor class that implements this interface. So you might have a type checking visitor, a code generating visitor, a pretty printing visitor.
So you've got the things, elements, and the actions,
Yeah.
visitors. How do they interact? What connects them?
The key is in the interfaces. The base element interface declares one crucial method. Usually it's called accept. And this accept method takes a visitor object as its parameter.
Okay, accept visitor.
Yep. Then each concrete element class assignment node, variable ref node, implements this accept method.
How?
It implements it in a very specific way. Inside the accept method of, say, assignment node, it calls a method on the visitor that was passed in, and it passes itself back to the visitor.
Whoa, okay, a bit of a callback situation.
Exactly. It looks something like this. Visitor.visitAssignment of the assignment node tells the visitor, hey, I'm an assignment node, visit me.
Ah, I see. So the visitor interface must have corresponding methods.
Precisely. The base visitor interface has to declare a visit method for every single concrete element type. So it would have visit assignment node, visit variable ref node, and so on.
A visit method for each type of thing it might need to visit.
Correct. And then your concrete visitors, like type checking visitor, implement each of these visit methods with the specific logic for that operation on that particular element type.
Okay, so type checking visitor would have the rules for checking assignments in visit assignment and the rules for checking variables in visit variable ref.
Exactly. All the type checking logic is bundled together in that one visitor class, but split out by the type of element being visited.
This sounds like that double dispatch thing you mentioned earlier. Can you elaborate on that flow? How does the right operation hit the right object at runtime?
Yeah, let's walk through it. Say you want to type check your abstract syntax tree. First, you create an instance of your type checking visitor.
Okay, got my visitor.
Then you start traversing your tree of element objects. Could be a simple loop, could be recursion. Doesn't really matter for this part.
All right, visiting each node.
For each element node you encounter, you call its accept method, and you pass your type checking visitor instance to it.
Current node, accept my type checker.
Yep. Now, here's the first dispatch. The runtime figures out the actual type of current node. Is it an assignment node? A variable ref node? It calls the correct accept method implementation based on that concrete type.
Okay, makes sense. Polymorphism.
Right. Now, inside that specific accept method, let's say it's the one in assignment node, it makes the second dispatch. It calls back to the visitor using visitor.visitAssignment. This.
Ah, so it uses the fact that it knows it's an assignment node to call the specific visit assignment method on the visitor.
Exactly. The specific method that gets executed ultimately depends on both the type of the element determined by the first dispatch and the type of the visitor. Since the visit assignment method's implementation is specific to type checking visitor in this case. That's double dispatch.
Wow, okay, that's clever. The accept method acts like a bridge, using the element's own type information to route the visitor to the right place.
It's a neat way to effectively add new methods to a class hierarchy without actually touching the original classes.
So let's summarize the benefits. Why go through this slightly more complex setup?
The biggest win, especially in systems that evolve, is adding new operations is super easy. Need new analysis, like say complexity calculation.
Yeah.
Just create a new complexity visitor class, implement the visit methods for each element type, and you're done. You didn't touch assignment node or any other element.
That's huge. Minimal changes to existing, potentially stable code.
Absolutely. That follows the open-close principle really well. Open for extension, adding new visitors. Close for modification, not changing elements.
What else?
Second big benefit, related operations are grouped together. All the logic for type checking lives inside type checking visitor. All the logic for code generation lives inside code generating visitor.
Right, better organization, instead of type checking logic being scattered across 10 different element classes.
Exactly. It improves cohesion, and third, it promotes separation of concerns. The elements are just data structures, essentially. The visitors contain the algorithms that operate on that data. Clean separation.
Okay, those are definitely strong points. But like most patterns, it's not perfect, right? What are the downsides? The trade-offs?
The main drawback, and it can be a significant one, is the flip side of the first benefit. While adding new operations, visitors, is easy, adding new concrete element classes is hard.
Ah, okay. Why is that?
If you introduce, say, a new function call node to your element hierarchy, you first have to add a new abstract method, visit function call node, to the base visitor interface.
Okay.
And then you have to go and implement that new method in every single existing concrete visitor class, type checking visitor, code generating visitor, pretty printing visitor, all of them.
Oof. Yeah, if you have a lot of visitors, that's a lot of mandatory updates.
It can be quite a bit of work and potential breakage. So the pattern really shines when your element hierarchy is relatively stable, but you expect to add lots of new operations over time.
That makes sense. A clear trade-off there. Any other drawbacks?
Sometimes, to allow the visitor to actually do its work, the element classes might need to expose more of their internal state than you'd ideally like.
How so?
Well, the visitor might need access to, say, the left-hand side and right-hand side of an assignment node to perform type checking. So the assignment node needs to provide public methods like get left-hand side and get right-hand side.
Right, which might expose implementation details.
It can potentially break encapsulation a bit. You're trading off some encapsulation for the flexibility of the visitor. You need to decide if that trade-off is worth it in your specific context.
Okay, that's another important consideration. So putting it all together, when is the visitor pattern the right call? What are the ideal scenarios?
Well, definitely when you have an object structure with, many different classes, different interfaces, and you need to perform operations that really depend on the concrete class of each object.
Like our compiler or document processor examples.
Exactly. And critically, when you have many distinct and unrelated operations you want to perform, if you only had one or two operations, maybe adding them directly isn't so bad. But when you have type checking, code gen, printing, optimization, validation, visitors start looking very attractive.
To avoid polluting those element classes.
Precisely. And the third key condition we already hit on. The pattern works best when the classes defining the object structure are relatively stable. If you're constantly adding new element types, The maintenance overhead on the visitors can become painful.
Got it. Stable elements, changing operations, that's the sweet spot.
That's the sweet spot, yeah.
Let's maybe bring in another example. You mentioned document processing. How about something totally different? Maybe a menu system for a restaurant.
Okay, interesting. Let's think about that. You could have different types of things on a menu. Menu item, like a specific dish, maybe ingredient within a dish, maybe even a menu section. Different kinds of objects.
Right. And you might want to perform operations like calculating total calories, total protein, total carbs, maybe even figuring out a health score for an item or the whole menu.
Yeah, exactly. Now, if you added calculate calories, calculate health score methods directly to menu item and ingredient, you'd run into the same problems. Duplication, tangled responsibilities.
Especially if ingredients are reused in multiple menu items.
Right. So visitor could work here. Your menu item, ingredient, etc., would be your element hierarchy.
Yeah.
They'd each have an accept method.
And the visitor.
You'd have a nutrition calculator visitor base, maybe. Then concrete visitors like calorie total visitor, protein total visitor, health score visitor.
And the calorie total visitor would implement visit menu item and visit ingredient to sum up the calories appropriately.
Exactly. It keeps the nutritional calculation logic separate from the definition of what a menu item is. If the chef adds a new vegan protein calculation, you just add a vegan protein visitor without messing with the menu item class.
That makes it really clear how it avoids that code duplication and centralizes the operational logic. Nice example.
Yeah, it helps visualize the separation.
Yeah.
The elements might just need a basic get state or get nutritional info method for the visitor to work with, keeping them relatively simple.
Okay, one last technical point. We mentioned traversing the object structure. Who's actually doing the walking through the tree or list of elements?
Good question. There are a few options, actually. Sometimes the object structure itself knows how to be traversed. Like if you have a composite pattern structure, the composite object can iterate over its children and call accept on each one.
Okay, so the structure drives the traversal.
Or the visitor itself can handle the traversal. This might be necessary if the order of visiting elements matters for the specific algorithm the visitor is implementing. The visitor would fetch children or next elements and explicitly call instara, accept on them.
Gives the visitor more control.
Yeah. And a third way is to use a separate external iterator object. You pass the iterator and the visitor around, and the iterator guides the visitor through the structure.
So flexibility there too, depending on the system's needs.
Exactly. It's not rigidly defined by the core pattern.
Okay, well, this has been a fantastic deep dive. I think for anyone prepping for those senior interviews, really grasping the visitor pattern is key. It's not just about knowing the mechanics, but understanding the why and the when.
Absolutely. Being able to articulate the problem it solves, avoiding modification of stable classes, separating concerns and discussing the trade-offs, particularly the difficulty of adding new element types, shows real design maturity.
It demonstrates you can think beyond just writing code to designing systems that can actually evolve gracefully.
It's a sign you're thinking about maintainability and extensibility.
So maybe a final thought for our listeners to chew on. Look back at systems you've worked on. Can you spot places where the visitor pattern might have simplified things? Maybe untangled some complex classes or made adding future features easier?
Yeah, and thinking forward, how might consciously separating operations from data structures influence your approach to new architectural challenges you face? It's a powerful way of thinking.
Definitely food for thought. Keep exploring these patterns, keep practicing explaining them. Thanks so much for joining us on this deep dive.
My pleasure. Good luck to everyone with their interviews.